Hi students, as a part of nanomaterials, today I'm going to discuss the properties of nanomaterials. In fact, I'm going to discuss the principles or basics to understand the properties of nanomaterials. The unique properties of nanomaterials is attributed to the two important concepts, that is quantum size effects, which is also called as quantum confinement, and surface to volume ratio. To be more precise, the novel properties of nanomaterials compared to that of bulk materials is mainly because of these two concepts only, that is quantum confinement and surface to volume ratio. And I strongly believe that without understanding these two concepts, we cannot understand the properties of nanomaterials so precisely. In this context, first I will discuss about these two concepts. The person who is depicted on the slide is a renowned person whose name is Norio Taniguchi. He was a professor of Tokyo University of Science. He is the person who had coined the term nanotechnology in 1974. Based upon his experiment on gold metal. In this particular experiment, he had taken the gold metal and reduced its size up to microscopic range, that is 10 to the power of minus 6 meters. And at this range, he noticed that the color of the gold remained as the same, that is yellow color. He did not give up. He continued his experiment. In this context, he still reduced the size of the gold to a nano range, that is 10 to the power of minus 9 meters. At this range, strangely, the yellow color of the gold had turned to red. Keeping all these observations in mind, he believed that there is a technology behind this color change from yellow to red, which became the preamble for nanotechnology. This color change grabbed the attention of the scientists towards the nano range, that is 10 to the power of minus 9 nano, 10 to the power of minus 9 meters. The scientists started to explore the things. In this context, they have studied about bulk materials in detail. This is the bulk material. In this bulk material, in a single unit cell, what is the unit cell? It is a simple part of a crystal lattice which repeats itself to generate a crystal. This single unit cell contains 10 to the power of 23 atoms. And as the bulk material is a combination of so many such unit cells, bulk material contains infinite number of atoms. Hence, they are closely packed, which you can observe in this particular image, because of which the atoms are compressed. And as we know that atoms contain energy levels, and as the atoms are compressed, the energy levels mix up. So in the bulk materials, the energy level of valence band and conduction band becomes continuous. You can see in this particular figure, continuous. When the size of the bulk material is reduced to microscopic range, that is 10 to the power of minus 6 meters, it has been found that the number of atoms in the whole material are only 1000 atoms. And as the number of atoms in the whole material were decreased abruptly, now it has been found that the energy level of valence band and conduction band became moderately discontinuous or partially discontinuous. And when the size of the material is reduced to a nano range, that is 10 to the power of minus 9 meters, it has been found that the number of atoms in the whole material are 10 to 15 only. And as the number of atoms in the whole material were decreased to a greater extent, it has been found that the energy level of valence band and conduction band became fully discontinuous, as there are fewer number of atoms left in the material, because of which the same bulk material in this range, that is in the range of 10 to the power of minus 8 to 10 to the power of minus 9 meters, will behave differently and exhibit different properties. If you see this figure, it is amply clear that after reaching the nano range, on further decrease of size, so you can see the bulk semiconductor over there. So whenever the bulk semiconductor is converted to nanocrystal semiconductor, and as we are decreasing the size of this nanocrystal semiconductor, further confinement is taking place. By which discontinuity is increasing. You can see from here. So it is increasing. Discontinuity is increasing, due to which the same nanomaterial of different size within the range 1 to 100 nanometer will also behave differently and exhibit different properties. This concept of confinement is called quantum confinement or quantum size effect. Now coming to the second concept, which is also very important to understand the properties of nanomaterials, is surface to volume ratio. In nanomaterials, the surface plays an important role. Now let us consider the cube, which is the bulk material. In this cube, there are three sides. 1, 2, 3 sides. Now, what would be the surface of it? The formula for calculating the cube surface area is equals to 6 into x square, where x is the side. So, number of sides in this particular bulk material or cube is equal to 3. Accordingly, 6 into 3 square, you will get 54. Now, what would be the volume of this particular cube bulk material? What is the formula for calculating the volume of a cube? The formula for calculating the volume of a cube equals to x cube, where x is the side. Now, as 3 sides are there, so totally 3 cube equals to 27. Now, what will be the surface to volume ratio for it? So, surface to volume ratio is 2 only. Now, whenever this 3-sided bulk material is reduced to 2-sided material, this is one side and this is another side, 2-sided material. Now, what would be the surface of it? 6 into x square, same formula. So, x is 2. So, accordingly 2 square. So, totally 24. Now, how to calculate the volume effect? Volume is nothing but, what is the volume? Volume is nothing but x cube, where x is the side. So, 2 cube, it should be 8. It should be 8. It is not 3, it is 8. Now, surface to volume ratio is 3. Now, whenever this particular material is still reduced to single-sided material, let us say that it is the nanomaterial. Now, number of surfaces are 6 into 1 square, 6, volume equals to 1 cube, 1. So, surface to volume ratio is equal to 6. Now, as we are moving from bulk material to microscopic material and to nanomaterial, what is happening to surface to volume ratio? In the bulk material, the surface to volume ratio was 2. In the microscopic material, surface to volume ratio was 3. Whereas in the nanomaterial, surface to volume ratio is 6. Now, as we are reducing the size of the bulk material to the nanomaterial, surface to volume ratio is increasing, and this increase in surface to volume ratio will contribute to the enhancement of properties of the nanomaterials significantly. How? We are going to discuss in the next class. When the surface to volume ratio increases, the greater amount of the material comes into contact with surrounding material very easily, thus affecting the reactivity. To summarize, because of these two concepts, that is quantum confinement and surface to volume ratio, most of the nanomaterial properties varies significantly when compared to that of the bulk material. So, based upon these two concepts, I will explain the properties of the nanomaterials in the next video. So, thanks for watching this video. Thank you.